Good morning, students. Our today's topic in the topic of periodic table is alkaline earth metals. These are actually group 2 metals, so they are also called alkaline earth metals. So concentrate yourself. A lot of concepts and ideas will be involved in this topic. So we are going to start. Concentrate yourself. Group 2 elements are metals. However, they are not as reactive as group 1 elements because they are having 2 valence electrons in the outermost shell, whereas the group 1 metals are having one valence electron in the outermost shell. So group 1 metals are more reactive as compared to group 2 metals. The reason is they are having one valence electron and they are having group 2 metals are having 2 valence electron. So to get rid of one valence electron is much easier as compared to 2 valence electrons. So this is the reason. So this is the point to remember. They are not as reactive as group 1 elements. The group 2 elements are called the alkaline earth metals. Their compounds are quite common in rocks in Earth's crust. And they are here: beryllium, magnesium, calcium, strontium, barium. The equations for the reaction are similar to the alkali metals. Almost they react in the similar way as of group 1. So calcium with water forms calcium hydroxide and hydrogen gas. Magnesium with oxygen forms magnesium oxide. And magnesium with ACl forms MgCl2 plus H2. So reactions are similar. Remember, never react any of the group 1 metals with acid. Group 2 metals get more reactive as you go down the group. The reason is same. As you go down the group in group 2, the atomic radii increases, because of which the attraction between the nucleus and the outermost valence electrons becomes weaker. So that's why they feel easy to lose their electrons. So this is the reason as you go down the group, they become more reactive. So this is the diagrammatical representation. Least reactive on the top. As you go down the group, they become more reactive. The reason is same as before we have read. They are least reactive on the top and becomes more reactive at the bottom. The reason is, remember that electrons are negative. They are attracted to the positive protons in the nucleus. As you go down the group, the atoms get bigger. Therefore, the outer electrons gets further away from the attractive force of the nucleus. This makes it easier for an electron to escape from a bigger atom, even though the positive charge on the nucleus is greater. As well as distance from the nucleus and other factor affects the attraction. So there are two reasons. So the distance also matters, because the distance increases, that's why they feel easy to escape. And the second is the force of attraction between the nucleus protons and the outermost electrons becomes weaker because of the distance. So these are two reasons. As well as distance from the nucleus and other factor affects the attraction of a nucleus for the electrons in the outer shell. The inner shells of the electrons shield the outer electrons from the pull of the nucleus. So this is the reason the inner shells of the electrons shield the outer electrons from the pull of the nucleus. So here is a video that will make your concepts more clear.
Elements like group 1 are also called alkalis, but these are the alkali earths. Earth here is an antiquated chemistry term, meaning that the substance does not dissolve in water or react to fire. But this is actually a mistake, in that these traits belong to the oxidized form of these elements, not the elements themselves. Like the alkali metals, the alkali earths all react with water, except for beryllium. It doesn't follow group trends. Unlike the alkali metals, though, alkali earths do not react as energetically. All of the group 2 elements are very soft metals, except for beryllium. It doesn't follow group trends. Beryllium is harder than obsidian or tooth enamel. All of the group 2 elements have distinct flame colors. That is the color that the metal emits when placed into a flame. The only exceptions are radium and beryllium, because it doesn't. Okay, beryllium, what's the deal? Why are you?
Now we are going to read some of their compounds and their uses. So group 2 metals and their compounds. First we are going to read magnesium. Magnesium ribbon and powder are very reactive in air. This leads to their use in the rescue flares and fireworks. So as you see in the air, the fireworks normally explode, and they are also used in as a rescue flare. So when they cut like here, the rescue flares burn very easily because magnesium ribbon and powder are very reactive in air. Next is Volkswagen Beetle engine parts have been made from magnesium for many years. More and more car makers are looking at magnesium to make a variety of the parts for new cars. In a Porsche 911, there is more than 50 kg of the magnesium. The reason is the metal is very less dense than steel or even aluminium. Therefore, you use less fuel because the car is lightweight, so less fuel will be used and pollution is reduced. The next compound which we are going to read is magnesium compounds. Magnesium and calcium compounds are common in Earth's crust. That is why group 2 metals are known as alkaline earth metals, because they are commonly found in Earth's crust. So this is the reason their name is alkaline earth metals. Magnesium oxide has a very high melting point. It is used to line furnaces. So because they are having very high melting point, they are used to line furnaces in which normally the bricks are cooked. Magnesium hydroxide is in milk of the magnesia. It neutralizes excess stomach acid, soothing in digestion. So sometimes when we feel soothing indigestion, we normally drink milk of magnesia. The function is it neutralizes excess stomach acid. The next is magnesium sulfate is found in the laxative Epsom salt. Next is calcium compounds. Calcium carbonate is the most common compound of calcium. Calcium phosphate is found in our teeth and bones. So this is the reason we require calcium phosphate, that is normally added in our toothpaste and in food. An adult has about 1 kg of the calcium in their body. Next thing that we are going to read is strontium and barium compounds. Strontium compounds give a crimson red flame and are used in fireworks. So normally you see the red color in the fireworks because of the strontium compound. Barium compounds are very poisonous. In fact, barium carbonate is used as a red poison. However, barium sulfate, which is insoluble, it is used in barium meals. A patient takes it so that their digestive system will show up on X-ray. So when we want an X-ray, particularly of our digestive system, the patient used barium meals. So because of which the inside of the body becomes visible in the X-ray machine. So this was the lecture, students. Read this lecture again carefully, understand it, learn it, and make your notes. Thank you so much.